Salam, peace be upon you. My name is Muhammad Layiq Siddiqui, the father of Holophase. Part 18, Canonicalization as Public Comparison Discipline. We have now reached a very important turning point. In the last part, we answered the central question of identity. We said that two descriptions are the same Phi-pattern if and only if they are related by a declared lawful equivalence that preserves the relevant invariance within the declared scope. That answer was necessary, but it is not yet enough for public science. Why not? Because real people do not compare pure abstractions in empty space. Real people work in laboratories, archives, classrooms, observatories, hospitals, field sites, software systems, notebooks, databases, and communities. One person records a pattern one way, another person records it another way. One team uses one file format, another uses a different one. One instrument adds noise, another smooths it. One observer aligns data before comparison, another does not. One program crops the edges, another pads them. One group rescales everything before analysis, another keeps the raw amplitudes. So even if identity is clear in principle, public comparison still becomes difficult in practice. This is where canonicalization enters. Canonicalization means a declared procedure for bringing descriptions into a stable, comparison-ready form. It may include normalization, it may include alignment, it may include registration, it may include formatting, it may include coordinate convention, it may include denoising, it may include standard scaling, it may include sorting, ordering, or relabeling. All of this can help comparison. But all of them are dangerous. Why? Because canonicalization is only a comparison tool. It is not the pattern itself. It is not the source of truth. It does not create identity. It only helps us compare what may already be identical or different. This whole part exists to protect that distinction. If we forget it, then standardization becomes ontology. Formatting becomes reality. The chosen comparison form becomes falsely treated as the one true pattern. And then science begins to worship its tools. Part 18 is here to stop that. A simple everyday story, the two addresses. Imagine two friends trying to meet in a city. One writes an address like this: Flat 4, 22 King Street, London. Another writes 22 King Street, Apartment 4, London. A third enters it into a navigation app as 22 King Street, Apartment 4, London. Now ask, are these three different places? No, they are different descriptions of the same location. But if a computer compares them character by character, it may wrongly treat them as different. One says street, one says st punt. One says flat, one says apartment. One uses capitalization, one does not. So what do? We apply a standard comparison procedure. We normalize abbreviations, we standardize capitalization, we reorder fields, we convert to a common internal form. Now, the system can compare them reliably. That normalization is canonicalization. But notice something very important. The standard form did not create the address. The standard form did not create the location. The location was already what it was. Canonicalization simply helped the comparison system recognize what was already the case. This is the first lesson of part 18. Canonicalization helps comparison. It does not create reality. Why equivalence in principle is not enough. Part 17 gave us the identity criterion in principle, but public science needs repeatable workflows. It needs pathways that many observers, teams, and tools can use without collapsing into endless ambiguity. Suppose two labs are recording the same biological signal. Suppose two telescopes are observing the same pulsar. Suppose two historians are transcribing the same manuscript. Suppose two musicians are annotating the same melody. Suppose two cartographers are mapping the same coastline. If each leaves the description in a totally different form, comparison becomes difficult, expensive, fragile, and error-prone. One person's coordinate origin differs. One person sorts entries alphabetically, another chronologically. One stores angles in degrees, another in radians. One uses left-handed orientation, another right-handed. One preserves raw noise, another filters it out. One records in meters, another in feet. In principle, identity might still be recoverable, but in practice, public comparison becomes unstable. So canonicalization is born from public need, not from ontology, not from metaphysics, not from the nature of the pattern itself, from the practical need to compare descriptions across observers, teams, and tools. This is why canonicalization belongs to discipline, not to essence. Let us define it clearly. Canonicalization is a declared procedure for producing a stable, comparison-ready form of a pattern description or artifact. This means it is not the pattern itself. It is not the same as equivalence. It is not the same as identity. It is not the same as truth. It is a procedure. And because it is a procedure, it has steps. Because it has steps, it has parameters. Because it has parameters, it has choices. Because it has choices, it has risks. And because it has risks, it must be declared. Canonicalization may involve many things: normalization of scale, alignment of coordinates, registration of images, noise reduction, sorting of components, file conversion, standard labeling, reindexing, phase and wrapping conventions, boundary padding rules, declared interpolation rules, unit conversion, common naming standards. All of these may help, but none of them are innocent just because they are common. Anything that materially affects comparison must be declared. That is the law of this part. Canonicalization as procedure, not truth source. This is the most important sentence in the entire chapter. Canonicalization is a procedure for comparison, not a source of truth. Let us say it more slowly. A pattern may be real even before any canonical form is chosen. Two descriptions may be identical even before canonicalization is applied. Two descriptions may be different even if canonicalization makes them look more similar. Canonicalization does not decide what is real. It does not decide what is identical. It does not decide what counts as invariant. Those were decided earlier in the identity framework. Canonicalization comes afterward. It is subordinate. It serves comparison. It does not govern ontology. If this order is reversed, danger begins. People start to think, the canonical form is the real object. Whatever does not fit the canonical form is noise. Whatever disappears under normalization was never important. Whatever becomes aligned must be the same. Whatever fails to align must be different. All of these are mistakes. Canonicalization can help reveal comparability, but it can also hide structure. So it must remain a tool, never a judge. A second simple story: the family photographs. Imagine a family trying to organize old photographs. Some are black and white, some are color, some are faded, some are cropped, some are rotated sideways. Some have dates written on the back. Some are scanned in low resolution. Some are originals. To compare them, the family decides to make digital copies. They rotate them upright. They resize them to one common frame size. They adjust brightness a little. They rename files using one convention. They sort by year where known. Now comparison becomes easier. People can see which photos show the same event, the same people, the same place. That is canonicalization. But suppose they go too far. Suppose they heavily smooth the images. Suppose they erase scratches and marks that actually mattered. Suppose they crop away the background that would have identified the location. Suppose they recolor black and white photos in misleading ways. Suppose they rename uncertain dates as if they were known. Now, canonicalization is no longer innocent. It begins to shape the verdict. It creates apparent agreement or apparent disagreement. This is exactly why Part 18 is needed. Identity versus canonical form. We must now lock the distinction clearly. Pattern identity means what the pattern is, under declared lawful equivalence and relevant invariance. Canonical form means one standardized representation chosen to make comparison easier. These are not the same. A pattern may have many legitimate canonicalizations depending on purpose. An image may be canonically represented one way for geometric comparison and another way for color analysis. A melody may be canonically represented one way for interval comparison and another way for harmonic analysis. A manuscript may be canonically represented one way for letter frequency study and another for semantic study. So canonical form is always purpose-shaped. Pattern identity is deeper. It lives in the invariant relation, not in the chosen standard form. This is why confusing canonical form with identity is so dangerous. It turns a comparison convenience into a false essence. A third story, the same melody on paper. Let us return to music because it makes this vivid. Take a melody and write it in staff notation. Now encode the same melody in MIDI. Now encode it as a list of intervals. Now encode it as audio waveform samples. Now encode it as node names in plain text. These are very different representations. To compare them publicly, you may decide to convert them all into one standard representation, perhaps interval sequence plus rhythm grid. That is canonicalization. Helpful? Yes. Necessary for practical comparison? Often, yes. But is the interval sequence the real melody and all the others unreal? No. It is simply one declared comparison form. It may be excellent for melodic identity, but it might lose timbre, it might lose expressive timing, it might lose ornamentation, it might lose microtonal nuance. So the canonical form is useful, but it is not the pattern itself. The pattern is what survives the lawful transformations relevant to the declared scope. The canonical form is just one comparison scaffold. Now we arrive at the heart of the danger. If canonicalization is applied silently, it can corrupt the science. Why? Because it can fabricate apparent agreement. Imagine two noisy datasets that do not actually match well. A strong smoothing pipeline is applied without declaration. Now both become similar. The researcher announces, they agree. But what agreed? The canonicalized outputs, maybe not the original structures. Or it can fabricate apparent disagreement. Imagine two descriptions that are really equivalent under a lawful transform. But one is resampled badly during hidden conversion. Now, comparison fails. The researcher announces, they differ, but the difference may have been created by the pipeline, or it can hide real structure. Suppose a defect signature appears in fine variation near a boundary. A hidden denoising step washes it out. Now the defect disappears from the comparison form. Or it can create false invariance. Suppose normalization forces all amplitudes into a shared range. Now, different energetic regimes look falsely equivalent. All of this means one thing. Undeclared canonicalization is a form of smuggling. It changes the comparison field while pretending it has merely prepared it. That is not allowed. Material impact and why declaration is required. Not every formatting change is material. Changing a file name may not matter. Changing line breaks may not matter. Changing font may not matter. But canonicalization becomes material whenever it affects identity verdict, equivalence assessment, comparison outcome, replay outcome, visible structure, boundary behavior, defect detectability, read depth, inferred invariance, or any conclusion drawn from the description. Whenever that happens, declaration is required, not optional, not understood, not hidden under phrases like standard preprocessing, not buried in private scripts, not assumed as obvious, declared. The procedure, its version, its parameters, and its rationale must be public if it materially affects the certified result. A fourth story, cleaning the fossil. Imagine an archaeologist uncovering a fossil. The fossil is covered in soil and mineral crust. To compare it with known fossils, the archaeologist cleans it. Dust is removed, loose debris is brushed away, fragments are aligned carefully. Images are taken under controlled lighting. This is canonicalization. But what if the archaeologist also files down some ridges because they look accidental? What if a missing piece is filled in with plaster but not marked? What if lighting is chosen to exaggerate one feature? What if break lines are digitally erased? Now comparison is no longer neutral preparation. It materially shapes the verdict. The fossil may now appear to belong to a different species, or may falsely resemble another specimen, or may hide what made it unique. This is why canonicalization requires discipline. Preparation is never automatically harmless. Part 5 returns again here. Canonicalization usually acts first on artifacts or descriptions, not directly on the pattern itself. That means we must keep the identity layers separate. A canonicalization pipeline may change: artifact form, description format, claim comparability, without changing the underlying pattern identity. If those layers are collapsed, confusion begins. You may think, the pattern changed, when in fact only the artifact format changed. Or the claim gained truth, when in fact only the files became easier to compare. Or the certificate is stronger, when in fact only a comparison-friendly normalization was introduced. So canonicalization must always be understood as operating within the representation and artifact layer, unless explicitly bridged otherwise. This protects ontology from procedural overreach. Because canonicalization is powerful and dangerous, it needs its own discipline. This discipline has several pillars. Declared pipeline. The steps must be listed. Declared parameters. If smoothing strength, scaling rule, registration tolerance, or alignment threshold matters, it must be stated. Declared version. If the procedure changes, the version must change. Otherwise, replay breaks. Reproducibility. Others must be able to run the same pipeline on the same input and get the same output within declared tolerance. Reversibility. Notes where applicable. Some canonicalizations are reversible. Some are lossy. This must be declared. Materiality assessment. It must be stated whether the pipeline could affect identity, equivalence, comparison, or replay outcome. All of this makes canonicalization public and disciplined rather than private and magical. Why standard preprocessing is not innocent. One of the most dangerous phrases in science is standard preprocessing. Why dangerous? Because standard often means nobody thinks they need to explain it. And that is exactly how smuggling enters. A pipeline can be standard in a field and still materially affect outcome. A field-wide habit is not an exemption from declaration. A convention may be useful, but if it shapes comparison, it must still be named. Otherwise, the entire field begins to confuse its tools with reality. This happens everywhere: in image analysis, in genomics, in climate datasets, in machine learning, in music transcription, in historical text normalization, in linguistic corpora, in economic indexing. What is called standard may simply be collective invisibility. Part 18 tears away that invisibility. Another danger must now be named clearly. Canonical form essentialism is the false belief that the real pattern just is its canonical form. This happens when people forget that the canonical form was chosen. They start to think the standardized database entry is the real object. The aligned waveform is the true sound. The normalized scan is the authentic image. The registered map is the actual geography. Staris, the compressed representation, is the pattern itself. But this is wrong. The canonical form is one disciplined public handle. It may be excellent, it may be necessary, it may be beautifully designed. Still, it is not the pattern itself. The pattern remains what it is, regardless of whether we have chosen one canonical representation, several, or none. So canonicalization must be demoted from essence to procedure. That demotion is one of the central achievements of this part. A fifth story: translating a poem into searchable text. Imagine a library digitizing all handwritten poems. The original pages contain line breaks, ink pressure, margin notes, spelling variants, and visual emphasis. To make them searchable, the library converts them into plain machine-readable text. This is useful. Now, thousands of poems can be compared rapidly. But what has happened? A canonical comparison form has been created. Has the poem been preserved entirely? No. Some things survive: words, order, maybe punctuation. Some things may be lost: page layout, visual spacing, ink emphasis, handwriting rhythm, material context. So if the scope is lexical comparison, the canonical text may be excellent. If the scope is manuscript identity or scribal style, it may be insufficient. Again, scope saves rigor. Canonicalization is never just better. It is better for this declared comparison purpose. For these reasons, Part 18 installs its own gate, the Canonicalization Declaration Gate. This gate asks, has a canonicalization procedure been used? If yes, has it been declared? Are the pipeline steps stated? Are parameters stated? Is the version stated? Is the pipeline replay critical? Could the pipeline materially affect verdict? If the answer to the relevant questions is no, the claim cannot be certified. This gate is not a side detail. It is essential because comparison in public science often flows through pipelines, and pipelines shape outcomes. So the pipeline must become visible. Replay relevance. Canonicalization is often replay critical. That means if another team cannot reproduce the same canonicalization on the same raw description, then comparison cannot be publicly verified. This matters enormously. A result may appear strong, but if its comparison-ready form depends on an unpublished script, undocumented software defaults, or hidden parameter settings, then the public cannot replay it. And without replay, public certification weakens. So whenever canonicalization materially affects verdict, replay discipline must accompany it. A declared pipeline is not enough if it cannot in practice be rerun. What Part 18 gives the framework. By the end of this part, several things become clear. First, identity and canonicalization are separated. This prevents a major category error. Second, canonicalization is relocated from ontology to procedure. This keeps the science honest. Third, comparison discipline becomes stronger. Different teams can now compare in declared public ways. Fourth, the path opens toward compression, minimal generators, and structural cores. Because once canonicalization is disciplined, one may ask, what is the most compact, stable, comparison-ready form? That question belongs to later parts. Fifth, replay becomes more rigorous. Pipelines are no longer hidden. These are not minor gains. They stabilize the public practice of comparison. We can now state clearly when a claim must be refused in this part. Refuse if canonicalization materially affects verdict and is undeclared. Refuse if the pipeline is unversioned. Refuse if parameters are hidden when they matter. Refuse if standard preprocessing is invoked without explicit declaration. Refuse if the comparison verdict depends on hidden normalization, alignment, registration, or denoising. Refuse if canonical form is treated as the source of identity rather than as a comparison aid. Refuse if replay depends on a private or unpublished pipeline. Refuse if the procedure erases relevant structure while pretending it is neutral. These refusal rules protect public comparison from becoming private manipulation. Why this matters beyond science? This part is not only about formal pattern work. It also says something deep about human life. We all canonicalize. We reduce people to summaries. We reduce complex events to neat narratives. We clean memories into comparison-ready stories. We translate messy experience into social categories. We normalize ourselves for institutions. We align our speech for audiences. We compress our lives into biographies. All of that is canonicalization. Sometimes it helps understanding. Sometimes it destroys truth. A person's resume is a canonicalization. A diagnosis is a canonicalization. A legal identity document is a canonicalization. A social media profile is a canonicalization. Useful? Often. Dangerous? Also often. Because the cleaned up public form is not the whole person. Part 18, therefore, carries an ethical lesson as well as a scientific one. Do not mistake the standardized form for the reality it helps you compare. That lesson matters in science. It also matters in love, law, politics, education, medicine, and memory. At a deeper level, this part completes a very beautiful arc in the framework. We began by saying there is no privileged absolute label. Then we said only relations are public. Then we said identity lives in invariance. Now we say canonicalization is only a disciplined aid to public comparison. All of this is one continuous moral and epistemic structure. It says, do not worship labels. Do not worship coordinates. Do not worship appearances. Do not worship pipelines. Do not worship standard forms. What deserves trust is not the favored representation. What deserves trust is the invariant structure that survives lawful transformation under declared discipline. That is the soul of Phi-pattern science. We now have something very important. We know when two descriptions are the same in principle. We know how to compare them in practice without confusing canonicalization with truth. So the next question becomes deeper and more structural. If a pattern can be identified and compared, what is the invariant generating core that makes that pattern what it is? What is the structural heart from which its stable identity flows? That is where the journey now turns, and that is the work of part 19. Always. Peace be upon you.